following is an introduction to using classes in Python. Classes are used by many different programming languages in order to implement object-oriented programming, which you may have heard about, and is a very powerful and useful technique. Here we'll just give some very basic introduction using a simple class that we'll define called circle. Here I have a file called circle.py, and we'll have a look at it. Circle.py has a simple doc string at the top and is used to create some basic properties of a circle. Here we have the radius of the circle, and then we've also set a color of the circle just for fun. We also have a few functions that can return, that can do basic calculations on the attributes of the radius. In this case, we have a function called diameter, a function called circumference, and a function called area. And these functions return what you'd expect, the area of the circle, using the radius of the particular circle. The way that we use a class object is to be able to, is as a template, if you will, for how to create different objects of the class. So we've already seen that different kinds of objects can have, that there's different kinds of objects in Python. We've dealt with strings, and we've dealt with integers and floating point numbers, and we've seen lists, and we've seen NumPy objects, and some of these even have operations and functions that you can use. For instance, we've seen NumPy, you can have an array object that you can take the transpose of it with myArray.t. So here we're defining our own class, and we're calling it circle, and we can have multiple circle objects, each with their own radius, and all able to call functions that will operate on its own object, on its own radius. So the class notation here, at the top of the file, I've included from math import pi so that we have access to pi used in the calculation of the circumference and the area. And then the syntax is class is the keyword, and then you type the name of the class, circle, and then give it a colon like usual, and then we indent the body of the class where we define the different kinds of functions and variables that will be inside the class. So in this case, the first function is a so-called init function, and this is a special function. It starts with 2 underscores and it ends with 2 underscores. So underscore underscore init underscore underscore is a special name that Python is going to recognize as as a function that I've defined so that when I create a new circle object, it automatically calls this function that can be useful for setting up the properties of my circle class. One thing that's a little bit different for class objects is this self keyword. Whenever we define a function inside of a class, the first argument is always self. And that's simply so that we have access to the particular class object that we're working with. When you define the function, the first argument should always be self, but when you use the function, you can pretend it's not there. Just ignore it and pretend that R is the first object. Now in this case, my init function, which has self comma R equals 1, R is how I want to set the initial radius of my circle object. And here I've given it a default value of 1.0 so that if I don't give it anything, it will just assume that the radius is 1. Then when I want to refer to the radius, I go self.radius. And that says, okay, radius, you are a member of this self class, of this circle class. If I had just written, for instance, if I had just written radius equals R, that would be perfectly valid, but radius would only be a local variable to this initial init function. It would disappear when the function is done, and it wouldn't be available in any of the other functions. So by going self.radius, I'm saying radius, you are a variable that's special. You are one of the circle variables. And then in other functions like diameter, I can use self.radius because it's one of the class's objects. It is part of the self class here. So whenever you want something to be defined so that it can be seen anywhere in the class, you'll want to use self.radius. Otherwise, if you just need it locally in the given function of interest, you can just name variables like you're used to and create new variables like you need to. So that's the init function. If I want a diameter function, then I go def diameter, and then the first argument is self. I don't need to pass it the radius because radius is a member of the class, and we can simply go return self.radius times 2, circumference, return self.radius times 2 pi, area, return pi times self.radius squared. Let's go ahead and show how to use this. So if we open up a notebook, we can simply go import circle, and now we have access to the this circle class. Or we can go from circle import circle so that we can use a little bit different notation. But for now I'm going to go import circle like so. Now we can type, let's create a circle object. I'm going to call it C1 equals circle.circle. So the first circle is needed because I'm referring to this circle file, the circle module. And the second is the actual name of the class. And that's it. So if I go c1.radius, it shows me that it's 1.0, and it defaults to 1 because I didn't specify a radius. So it said, okay, you didn't tell me what it was, so I'm going to use 1.0. If we type 2.2, then when we create it and output it, now the radius is 2.2. Notice that I didn't have to do c1.self.radius, and that's because only inside the class definition do I need to worry about this self business. When I declare a circle and use it, c1 as circle.circle, I can just access the elements of that. I can create another circle, c2 equals circle.circle 5.5. And then I can print c2.radius, maybe print c1.radius, and then I can see I get the different radii of the two different circle objects. I can call the different functions like print c1.area and print c2.area. And it computes the area of these two circles based on the radius that we've already set for the circle. I can reset the radius if I want. I can go c1.radius equals maybe 25, and then c1.diameter, maybe print that out, print. And we can see that the diameter, whoops, it's a function. We can see that the diameter is 50 when we have the radius set equal to 2.25. So this is a pretty nice way to just create more general objects that can do that can collect groups of variables and can have functions that can operate on those variables, sort of like a self-contained little container for creating your own types. Here I've also set a color. I've set it equal to blue, so we could go maybe c2.color, and if we print that we get the color is blue. We could assign it to be something like red, and then if we print it out, print c2.color, we can see that the color is now red. And we could do that with any number of attributes that we might be particularly interested in. There's nothing particularly special about this, having this in a separate file. If we wanted to, we could set it in, we could define a class locally here. So let's try one. Class, maybe ideal gas law. And then inside we can go like self.rgas equals 8314.46 joules per k mole Kelvin. And then maybe we have a function like def p from nRTV, and we'll pass in n and t and v, something like this, and maybe leave off the n, t, and v because we already have the ideal gas. And then we could go p equals n times r gas, self dot r gas times t divided by v, and then we could return p like so. Okay, and it's complained we must have made an error in here. What did we do wrong? Name self is not defined. Oops, self, comma. Okay, and class ideal gas law. Let's go ahead and get rid of this. Sorry, just put it here. We'll just define it right there. Notice that I didn't put an init function in this. So if we do that, now it's happy. Okay, much better. And I guess we can put an init in there, like def underscore underscore init underscore underscore self. And then we could call this, put this function here, which we would like to be more general to the class. Like that. There we go, much better. Now we can create a class object, like maybe IG equals ideal gas law. Give it parentheses, and then we can go ig.p from ntv, and then we can simply call it with like 1 mole and 400 Kelvin and maybe 1 meter cubed, and it returns the pressure in pascals for this particular function. So pretty straightforward to use those, and that's the basic idea behind setting these classes.